So welcome to my video workflows where I'm going to be showing you how to script using Lsystems, and then from that we're going to generate this kind of structure here, and then we're going to move into 3ds Max and use Tyflow to create this bio-rock sort of growth over the top of it. So I guess just a quick word about all the different sort of programming languages and the way you can kind of go about this. I went into this not having any kind of experience in programming, so I definitely tried out a few different ones. It seems without any experience, C Sharp turned out to be one of the best options just because it's so well resourced and it's quite mature. It's relatively easy to understand the logic, much more so than, say, 3ds Max Script, which was my original intention to learn in 3ds Max Script. But yeah, so we've got a bit of a workaround using Rhino, but I think in terms of learning how this stuff is able to be applied, it's best to sort of take the path of least resistance. So that's why we're going through Rhino Grasshopper. And I also, I mean, this kind of programming and software exists in many sort of instances. Probably the best example being Houdini. But I think there's real value in just sort of going through this stuff step by step, because often when we're doing parametric modeling or working with simulations, we don't really understand how it's working. We're just kind of applying it. But I think then your projects can tend to lose meaning that way. So building it from the ground up, I think, yeah, is worthwhile. So yeah, we're going to be using C Sharp, as I just mentioned, and I think the best way, there's quite a steep learning curve, and not a lot of it's going to make sense. But my approach is basically just to follow along with the videos and then probably rewatch them again, and just figure out by doing it step by step. There are a few things that you can kind of do a bit of reading on just to speed up the process and get a concrete understanding. So if you head to Microsoft's website for C Sharp, they will give you a reference for a lot of these examples that we'll be using. So the first one is a string, and essentially that is just a string of characters smashed together. That's going to be super useful for building our Lsystems, which I'll get to in a minute. Character variables are a way of calling up these characters and perhaps performing a command with them. So you could apply an instruction to your script every time it executes and finds the letter F, for example, might be used to tell your geometry to move forward or something like that. For loops, these kind of execute. You might give it a test to say, is this statement true or false, and run through a list of possible conditions, and then return an answer. And you can specify how many times you want it to loop through. So it's quite powerful in that way. And a function is basically just setting up a task for your script to run, and then it's gonna at the end of that is going to return a value or a piece of information that we can use. So yeah, a lot of this stuff will probably not make much sense, but once we get into the videos themselves, they'll get a bit more meaning. New just creates a new instance of a type. So if we wanted to create a line or a point or a list or something like that, then we would just type in new and then the type that we're trying to create. So new line, and it's just a way of telling the script that that's what you want to do. And finally, another important concept is this idea of arrays. So when we're working with data in scripts, we need a way of storing information and accessing it. And an array is just basically a list of information or variables of the same type. So you might have a list of points in space that you want to manipulate or access in some way. So yeah, coming back to our Lindenmayer systems, these were developed by Arsted Lindenmayer, and he basically figured out a method for expressing the growth patterns of plants in an algorithm. And these systems can pretty much be written into your code so that you can simulate sort of like the growth of a plant. So these L systems, there's many layers to them and they get increasingly complex, but we can work with a fairly basic example, and there's always sort of two things within an L system. So there's a system by which you're creating a pattern, and we're going to refer to this as a string. So your string might be A, B, A, B, A, B, A. And then the way that we arrive at this is through our axiom or initial string. So this is kind of like, we might start with B, and then we've got a specified number of iterations. So we're going to tell our script to create 1, 2, 3, 4, 5, 6 iterations. And this can kind of correspond to, the branches of the tree shape that you're building up. And then, essentially we've got what's called a replacement rule. So every time our script hits the letter B, it's going to say, when we hit B, introduce AB. So we get A, and then AB, and so on and so on and so on. So it's getting increasingly complex. So we've got this string of letters, but I guess what does it actually mean? Well, the interpreter part of a Lindenmayer system basically allows us to interpret these strings as a set of instructions for a geometry. And so turtle graphics were kind of designed to interpret these strings, and so we translated into this code. So from the string we can derive these different character variables, like F for move forward, plus to turn right, turn left, save position, start a new branch, save position, end the branch, and X to insert a new replacement rule, kind of like what's happening here. So if we look at this on a graph, we can see that we've got F occurring 3 times in our string, and that has given the instruction move forward 1, 2, 3 times. Then we have a minus, and that's instructing us to turn to the that should be turned to the right, sorry. And then we're moving forward 2, and so on and so forth until you kind of complete this path. And then another layer of complexity. This is kind of like the very first layer, but in order to actually create these branching structures and not just kind of going around in a loop, we have to have the ability to move up and then come back and go in another direction. So that's what brackets allow us to do. And this is just a quick overview of the script that we'll be creating. I should point out that we'll be relying fairly heavily on a tutorial by the Computational Architecture Research Lab. So we're more or less copying along their code to create this Rhino script for an L system, which is pretty comprehensive, and I recommend checking that out. But that will kind of get us about half of the way, where we'll be able to generate these 2D L systems, but we will be building on this code to make the shapes 3D, and also then take them into 3DS, as I said before. As we've just been talking about our generator and interpreter, they're kind of represented here as 2 different blocks of code. We have our initial starting conditions and our replacement rules filtering in through here. This is our number of iterations for the branches. And yeah, so it goes through this piece of script and we get our output, which is the string. And then the string feeds into the interpreter, which then, yeah, allows us to create geometry in Rhino. So let's take it. Oh, and these examples here, these are from Houdini, which has a really comprehensive document on, yeah, how Lsystems are generated and how you can make them yourself within their program, but they're actually able to be, you know, if I wanted to take this rule, for example, we can put that straight into this this generator and it should be able to recreate that shape for us. So let's take a quick look in Rhino and see what that looks like. Here's our L system here, and we've just got a rule. Let's see what happens when we copy and paste in from that website. Okay, yeah, this one's quite complex, so we might just skip back to this example for now. But yeah, as you can see, we have this kind of 2D set of splines, and we can change the angle to get some pretty interesting patterns occurring. Yeah, and within this, if I were to double click on one of these components, you can see all our script describing exactly how these rules should work. So this is just kind of an introductory video to show what we'll be doing, and yeah, thanks.